The last couple of days were very, very brief things. I didn't bother to record anything. This will be a little bit longer. So we talked about word equations and how they're better than full-on sentences, but in the sense of efficiency, but it's still more efficient to use the symbols. So we'd have iron and oxygen react to form Fe2O3, or you could say iron 3 oxide. It's not immediately obvious it's iron 3 oxide. So if the point is brevity and efficiency, then making you stop and figure it out probably isn't good. But you do know your elements. You do know your elements, and so you can say the elements here, iron and oxygen, make Fe2O3. So kind of a reading system. How are you doing, Isaac?
I'm fine.
Good, good.
Isaac, if you don't come to school, you can't participate in the dance concert.
You for real?
Yeah.
I'm on my way to school right now. Hold on.
In person today?
Yeah, if you're not an online student.
If you're not, he is an online student.
No, he's not. He's in person now. Not anymore. He's in person.
Okay, well, on Monday he was. Let me just double check here before you get off the line here. Let me just double check and see the. Let me just stop the share.
Get marked after their most of the stuff.
Really? Even though, oh, okay. Let me just check. Do, 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 do. Hey guys. Covers both of you?
Yep.
Thank you. Nope. Nope. Remote full time.
Oh, well, he's been coming.
That's a different story.
And
Yeah.
I have another class with him in the picture that he was they were trying to get him in person. He probably in a minute.
All I can say is.
Well, just come just in case.
Well, all I can say is right now, officially, he's remote full-time, and the other day when he did come, registered as remote full-time, he got sent home. So
I did not get sent home. They just sent me right back to class.
Oh, they did?
Yeah.
Okay, well, okay. So anyway, it's up to you what you do, okay? You've shown up to this class, so you do have some commuting time if you need to get in for second period, okay?
Okay.
All right. Be wise. All right. So where were we? Oh yes. Let me start sharing again. Chemical reaction. Right. So, like I said, a little hybrid way of reading this out loud or thinking it out loud in your head. That's when I read. I often do that. Mason, head down and ask out things. So iron and oxygen make Fe2O3. Again, there's a moderate amount of memory you need in order to know Fe is iron, but please do not just say Fe plus O2. You write that, but you don't say it. Okay, so this is the skeletal equation. It doesn't really say how much of each thing, it just says what it is. This is qualitative, not quantitative. There's nothing wrong with qualitative. Sometimes you don't want quantities getting in the way. However, almost always in real life, you do need to know the quantities. So, but you have to do this first. Kind of like before you can get the molecular formula, you have to get the empirical formula from the last chapter. You don't want to stop with the empirical formula. Hi, Amaranth. You don't want to stop with the empirical formula, but you can't just go straight to the molecular formula. Somebody had to figure it out. And so you want to do that, follow that road, or else you'll never get there. Let's see here, 28. All right, so again, you have left is the reactants, right is the products, and you need to say what state of matter they're in. Now, if you'll notice on the bottom of the screen here, you'll see iron S plus oxygen G reacts to form Fe2O3S. And S is solid, L is liquid, and G is gas. And when you actually handwrite them, they're in cursive. Say again.
I can see the.
Can't see the. Okay.
So it's not so it's not that I can see that here. It's the other. It's because I don't have my glasses.
Oh, okay. All right.
Is it on the? Is it sharing stuff?
It is. Yeah, if you want to get on the Zoom, yeah, if that helps. All right. And almost always, you'll see the state of matter. This comes in handy later. Right now, it may seem trivial. Well, what state of matter? What does it matter? No pun intended. But it does actually come in handy later. It's just we won't get to that this year. But just know that it is handy later to know how fast things are going and what's going on with the behavior of matter in nature. So you'll notice that the iron and the rust are solid, and this makes sense. You've seen them, right? And you know that oxygen is a gas. It's not really any mystery here, but we practice on the things we know, and then when we do the things we don't know, then it'll make more sense to us by analogy to the things we do know. All right. Often there is a catalyst, and that you've heard of a catalytic converter in your car.
Yes. Cadillac?
Not a Cadillac, catalytic converter.
Oh, Cadillac.
Yeah. Cata. So like cation, catalyst. Cata, like a cataract, not just, the white stuff in your eyes. But a cataract is a waterfall. And so that's one reason why they're called cataracts, is they look like there's a waterfall in your eye. It's just white and foamy. Anyway, so kata means falling. So the cation, the charge goes down. You lose an electron. Well, a catalyst makes the energy go down in order to do the reaction, and it isn't used up. It's just there. And so, for instance, magnesium oxide helps and a lot of other things like your skin, helps hydrogen peroxide turn into water and oxygen. And you'll notice here that it's L. I'm not a big fan of Arial font because L looks like capital I. Let me just switch this over to what I am a big fan of, Georgia. There we go, Georgia. Now an L looks like an L. Actually looks like a very skinny Z, but whatever. All right, so, hi Taj. Make a note that you're here. All right. Again, it isn't on the left or the right. It's in the middle. It's what makes the arrow happen, and that's why it's put at the arrow. And so that's why that symbol works. Okay, we put a catalyst there. We also put heat underneath. They put it on top, but we usually put it underneath because that's literally, you usually put heat under something, like you put a pot of water on a stove to boil it. And again, these are other symbols. Now, plus, arrow, this two-way arrow is more useful later on. You don't need to worry about it right now. Solid, liquid, gas, we're not going to worry about plasma, if you know about that state of matter. Aqueous means it is in solution. Some people say aqueous. Do not say liqueous, okay? I did that once, and yeah, it was embarrassing. So, aqueous for aqua, and it's dissolved in water. Now, once in a great while, you will have a chemical that is dissolved in some other solvent, but probably not even in college, you're probably not going to do that. Water is the solvent of choice. All right, so in order to do this skeleton equation, you've got to be able to read and picture. Okay, you got to know what all the parts are. So hydrochloric acid reacts with solid sodium hydrogen carbonate. The products formed are aqueous sodium chloride, water, and carbon dioxide gas. Write a skeleton equation for this chemical reaction. So the first thing you have to do is you have to remember what you studied in previous chapters, water acids. So what is the formula for hydrochloric acid? It's an hydroic acid. I almost tried to put my cursor over on the board over there. Oops. Hydroic acid. That means there will not be any oxygen involved. If it's got hydro-ic, hydro shows you there's no oxygen involved. So the formula is rather simple. Did I hear somebody say it? Yes?
Will there be H and Cl in it?
Yes.
I don't know the numbers.
Not HCl3. Say good.
I don't know the numbers.
All right. You do not have to say any numbers because it is one of each. One hydrogen that has a +1 charge and one chloride that has a -1 charge, or I guess I should say, in your perspective, H over here and Cl. Just HCl. That's it. Hydrochloric acid is HCl. So that's the first thing. You have to write that down as a formula, so HCl. Then we have sodium hydrogen carbonate. So sodium is going to be Na, but then what is hydrogen carbonate? Keep going. Close. It has a charge of 2. No, not 8. No, see, the charge of carbonate is 2-, but the number of oxygens is not 2. 3, right. Don't worry about the charge right now. Okay, so because it's a solid, these charges are going to be balanced out. So for right now, we've got carbonate, we've got a hydrogen with it, so it's HCO3, and we've got sodium. Now we do go back and think, well, what was carbonate to begin with? Well, it was a charge of 2-. If we add an H to it, then the H and one of the charges for carbonate go away. So we have a 1- now for HCO3. So it's HCO3 1-. And we have sodium. So how many sodiums do we need to match that up? We have hydrogen carbonate that's -1. We have sodium that's +1. How many sodiums do we need? 1. We need 1. We need 1 sodium. So in all of that, the only thing that has a little number is going to be the oxygen. So it's going to be NaHCO3. NaHCO3. So I'm not going to add these in. Well, I can add them in at the bottom. HCl. And I really, really, really don't like Arial font. And they don't have a recent one, so I got to go back down here. There we go. Because everybody thinks, oh, it's HCl. No, it's HCl. There are only 2 atoms there. And then sodium, hydrogen, carbonate. Oops. And because it's PowerPoint, I can put in a subscript somewhere. Be sure anyway. I could on Word. Insert. Might be. I'm looking for symbol. Oh, there it is. Word art? I don't know. There we go. Got to go all the way here. Okay. There we go. And then, of course, I got to go back. Home, font, undo subscript in order to put in the comma. There we go. So it's not so convenient, but it's still better than Google Forms. All right, so sodium hydrogen carbonate. And then the products formed are aqueous sodium chloride. So what's sodium chloride? It's going to be a bit like hydrochloric acid. NaCl, right? And water. Oops. I'm not even going to highlight that. Yep. H2O and then 20. There we go. Then I'll highlight this. I could just shrink it, but no, I'm going to go up here and do it the right way. There we go. And carbon dioxide. Die. CO2. Yep, CO2. CO2. Select it. Oops, not the whole thing, just the two. Home. Subscript. Done. Okay. So that's the first step, is when you read it, you've got to see in your mind what the formulas are. And if you can't, then you got to write them down. It's not going to be easy to have 5 things floating around in your head. Okay? It's not going to be easy to have 5 things floating around in your head, so you have to write them down. I know some of you have an allergy to notes. Okay? But I'm telling you that your head can't hold all the stuff it's going to need to anymore. All right? Maybe it did that in middle school. But you've got to put things down on paper because your head just isn't big enough. That's no insult. It's just saying that, you know, there's a lot of things to float around. So now that's not the equation, but this is step 1, is interpreting the English words. Now, go to the next slide. So you do that, the correct formula. Then you have to have the state. And I'm not going to write it out here, but if you have these things, you know, this is solid. You know, sodium chloride is aqueous. You know, there's water, so that's liquid. And you know, there's carbon dioxide gas. The only thing that you don't necessarily know is hydrochloric acid. And hydrochloric acid, I'll just tell you, is always going to be AQ. Because if it's not, you've got a very poisonous situation, because it's floating around as a gas, and then you're in big trouble. Big trouble. All right. By the way, what does this actually mean? Like, if you were to visualize this, what would be happening? What is the normal word for sodium hydrogen carbonate?
Hey, Mr. Bowden,
Yes, Isaac.
is it okay if I leave because I'm on my way to school?
Yeah, I figured you did already.
Oh,
Yep.
no, not yet. Okay.
Yep, I understand. Drive safely, or ride safely, whatever. Okay, so sodium hydrogen carbonate, NaHCO3, has a normal name. I'll give you a hint. You can buy it in the store.
Salt.
Very close. NaCl is going to be salt. So it's not quite as common as salt. It comes in a little orange box. Orange, yellow.
It just will come in a box.
Orange juice
Wait,
will come
no.
in a box.
Oh, it comes in a bucket.
Ding, 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 ding. All right, somebody sent me a private message, which is correct. Yeah, the second thing you said there. But let me hear from other people.
Oh, wait, is baking soda?
Ding.
Yeah,
Baking soda, yep. Arm and Hammer. Arm and Hammer. Now, if you put baking soda in orange juice, you'll get the same thing, because orange juice is an acid.
Exactly.
It's a weak acid. It won't be quite as bubbly, so you may be disappointed. But it'll still do the same thing. It'll still make carbon dioxide. It'll still make salt. Yeah, so you have a salty, bubbly water with you know, all the orange stuff in there. You don't want to drink it, mostly because you never drink science experiments. Okay. That can help. Yeah, it's very bitter, isn't it? Well, it's supposed to get stuff out of your stomach gas-wise, but if other stuff comes too, then yeah, it's a benefit. But there's nothing like that after bowel feeling. Cold sweat. All right. Anyway, so don't do that just for the kicks of it. But if your condition without it would be worse, then the medicine hopefully is better than the condition beforehand. If the cure is worse than the disease, then stop. Okay. So, yes. Now, normally, you do the baking soda thing with the volcano. You do it with acetic acid because you can also buy that very easily at the store. Vinegar, just white vinegar, Heinz white vinegar or whatever. And then you've got yourself the classic second grade, baking soda volcano. But HCl will do it just as well, if not better. But you're not going to buy that at the store. This is literally actually what is in your stomach, though. So when you drink the baking soda and water, this is the reaction you're doing. This is literally the reaction you're doing. And so if you have a little too much, then yes, you'll have salt water in your belly. And your belly knows to get rid of salt water. Salt water. Yep, salt water. It knows to get rid of salt water. Just like if you're in the ocean and you drink some of the salt water in the ocean. Have you ever gone to the ocean?
Yeah.
And if you drink some of the seawater, you might get sick to your stomach. Did you like accidentally like drink some of the seawater? No, okay. Again, don't test this out.
Hey, if you drink some, it's gonna make you sick.
Right, might make you vomit. Yeah.
I can't drink some.
I mean, a sip or two isn't gonna hurt, but although it'll taste bad.
Yeah,
But
it tastes nasty.
it does, yeah. Well, there's all those living things in there too. That
Wait, hold on. Wait. When I went there, I forgot all about that stuff in there.
I mean, it's cleaner usually than lake water.
So it's like fishy.
Yeah. Yeah. Yep. And remember, all animals have to eat, and if you eat a lot, then you do what a lot? Exactly, and that just there's nowhere for it to go in the ocean.
Why do we look at so blue?
Well, that's because the sunlight refraction through there. So
Probably green.
on cloudy days it looks gray, changes.
What?
Okay, so you have to have the state. You want to separate the reactants from the products with an arrow. So we'll get there. And then you need to use the plus signs for the final touches. Okay, so you've got these reactants, and they react to form these three things. You've got you've identified what they are. You've put what state of matter they're in. And again, they never really said it, but I did. Hydrochloric acid will always be in water, so it'll be aqueous. If it's a gas, you better run. And then you change it into the correct formula. So we did that a little while ago, and you'll see there, solid, aqueous, aqueous, I don't really care how you say it, AQ anyway, liquid and gas. Aqueous and liquid are not the same thing. Being in water doesn't make salt a liquid. It's just dissolved in there and floating around, but it is not a liquid itself. But water is a liquid, and it'll never be aqueous. Okay, then we can put it all together. The symbols, the states of matter, the arrow, we've got the products on the right, the reactants on the left. There's the bubbles. Here's the salt. Again, you want the bubbles to help force other gas out of your body. But the salt, too much, and it'll make you hurl. And this will also take away. You want the HCl to go away if there's too much. If there's heartburn in your stomach, then you want it to go away. So it does a lot of good things. Burp, take away the acid, the burning, but it may make you get sick to your stomach. Okay. So why, if we can just use everyday words, why do we bother with an equation? It's a whole process to learn. It's a whole jargon. Is it just so we can keep uneducated people out? It could just be us happy few discussing things together. Question's been asked before I get to that. Do reactants always make three products? No. Sometimes reactants make one product. Sometimes they make two. Sometimes they make three. It depends totally on the actual reaction. You are not going to memorize very many reactions. There will be one we'll get to later that you do need to know because it's important for biology as well. But it's no. The number, there's not a rule for the number, whether it's going to be more or less or equal to the number of reactants. It'll be somewhere near there. So if you've just got a few reactants, you'll have just a few products. Any more than that, and you're in like third year of college. So hopefully that helps clarify that. All right, so why do we bother? What advantage does an equation give us? Well, how is this better than the sentence we had before? Remind you of the sentence up here. Hydrochloric acid reacts with solid hydrogen carbonate. Products formed of aqueous sodium chloride, water, and carbon dioxide gas. Well, it's just easier to read quickly once you learned how to read. Just like there was a time, and I have a 3-year-old who doesn't know how to read. If you read the book to him a lot of times, he knows the words because he's memorized it. But he doesn't really know how to read. My 7-year-old, though, does know how to read very well. Well, I should say well enough. And now it's a lot easier than just, me telling it to him. He can read things to me. It does show everything that's relevant. It does say how many reactants and products. Well, yeah. It shows which way it goes. So we don't put these things together and get these, okay? You can't. If you just mix these, if you get salt and water and carbon dioxide together, you're not going to get these two things out, okay? These things go in one direction, not the other. And if there are catalysts, which you don't really need to worry about, then those are there too, okay? So we'll get to balancing another time. I'm going to go ahead and stop here and give you the balance of the time, I guess 19 minutes for your work. And any questions before I stop the recording?